ch4p86. Simone has been absent and does not know the difference between the graph of y is less than or equal to 2x minus 2 and the graph of y is less than 2x minus 2. Explain thoroughly so that she completely understands what points are excluded from the second graph and why. Starting out here, I have set up 3 coordinate planes just so that we can kind of explore and explain everything together here. The first one is just our slope-intercept form of the equation y equals 2x minus 2. Let's go ahead here and let's plot this graph or this function on the coordinate plane. So we've got, let's see, our y-intercept at -2. We're going to rise 1, 2, run 1. Rise 2, run 1, rise 2, run 1. Let's go down 2, back 1, down 2, back 1. Alright, there, and I'm going to use my little line tool. You should use a straight edge if you're graphing it. Let's see here, I want a straight line. Let's make it red so it pops there a little bit. And let's put our arrows on the ends there. So let's see. We're gonna have, should look something like that. Now, why is this graph right here and why is it the way it is? Well, we know this is a representation of all the solutions to this equation. I could choose any point off of this line, substitute the corresponding x and y values in, and it should make a true statement. Let's go ahead and do that for one. Let's see here. This was 0, -2, so we went down 2 and back 1. Let's plug in this point here. Let's plug in the point -1, -4. Let's see what we get. So I'm going to put my -4 in for y, and I'm going to put my -1 in for x. So -4 equals 2 times -1 is -2, minus 2 would be -4. If that's correct, that is a solution. If we plug in any other points that aren't on the line, they would not make a solution to this. So all of these values make it true. So we can even write there, let's do that. Let's write all values of, that's supposed to be of, not on. Of x and y on a line are true. Therefore, right, they're going to be solutions that make this statement true. Now, when we do y is less than or equal to 2x minus 2, we should end up with the line in the exact same location. So we've got our -2, let's go back 1, down 2. Alright, let's go back to our line tool. Let's put that on there real quick. Sorry, bear with me. It'd be nice if it just kept everything the same. Alright, so let's see. That's not what we wanted to do. Thank you for switching on us. There we go. Now, what this means here is we're saying all the output values, or y values, have to be less than or equal to 2x minus 2. And if we put in our point -1, -4 here, it would still work. Okay, so if we put in our point there, -4, let's see, -1, -4. If we put that in here again, then we're still going to end up with -4 is less than or equal to -4, which is true. So that is a solution to this one. However, we also have solutions over here. If we choose any point that is underneath our line, let's say for instance, let's go down 1, 2, 3, 4, 5, 6. That looks like a nice point. Yay, let's use that one. This is the point 0, negative 6. Let's plug it in. Negative 6 is less than or equal to 2 times 0 minus 2. We end up with negative 6 is less than or equal to negative 2. That is true, which means then that all of the values on this side of our line are going to be true. So we'd want to shade in this entire side of the graph. I'm going to shade sort of to the best of my ability with the markers I'm using. So that means these are all solutions in addition to the line. So if we're going to write that, we'd say all values of x and y, or all the points on the line and under the line are true. So these are all solutions. Let's look at the last one. We have y is less than 2x minus 2. So I'm going to do that here. We've got our y-intercept on back down 2. So it's the exact same graph in terms of the points that we're looking at. However, this time here, if we took our point here, and this is that same point, we have that point negative 1, negative 4. If we take that and we plug it in here, we're going to see that negative 4 is less than 2 times negative 1 minus 2. Well, this would be negative 4 is less than negative 4, which is false. So we're going to end up saying that the points on this line that we would have here are not true. So this is still a boundary that we're using, but we need to represent it differently. So remember, then we need to take it and make it a dashed line. Let's do a dashed line here. We'll still do red, make it pretty, just like the other. So this is how we represent that this is a boundary point, but these are not solutions. Now, what about that point 0, negative 6? If we plug that in here, is it going to make it true? Use that point again, that 0, negative 6. Well, we're going to say that negative 6 is less than 2 times 0 minus 2. We get negative 6 is less than negative 2, which is true. So our solution is still going to be underneath here because we're talking about all the y values that are less than our 2x minus 2. This is our 2x minus 2. These are the y values that are underneath it. So in this case here, our solutions are not going to be the points on the line, but it's going to be everything underneath. So we'll say all values of x, y, are all our points under the line are true. We'll put points on line are not true. Take it and plug it back in to see it there. So hopefully this explains thoroughly enough why the graph of y is less than 2x minus 2 is going to be different than y is less than or equal to 2x minus 2. This one we include our line, it's solid because these values are solutions. If we look at this one, these are not solutions, just the ones underneath. This is problem 4-86. Hope this helped clarify if you needed help with this problem. This is Mr. Boyd signing off.